Hi everyone, today we're going to see special position in a binary matrix problem. So according to the problem statement, given your rows and columns, you have to find whether a special position I comma j where the matrix I j equal to 1. So in the matrix, we have to find position where in rows and columns there should be only one. So the best example is here. So here 0 0 is having only one. So row 0 and column 0 1 1. Row 1 column 1 there's only one, and similarly row 2 and column 2 there's only one. So this would help us to understand the problem statement better. So we have to find the one in both rows and columns. So the approach we're going to follow is it's two pass. So what we're going to do is we first check for ones in the matrix and create a counter for columns, and then you check for ones in the rows and get the index of the column with only one in the row, and then you map that particular column index with the counter and get the resultant output. So that is what the algorithm would be for today's problem is. So let's start coding. So result would be 0, and the column counter is a dictionary. So we'll iterate over the matrix. So length of mat. So this should be j and length of mat of 0. And if mat is 1, create the counter, initiate the counter. Then column counter of j. So j is the column. So this should get the counter value. So now the next is we need to get the check for rows. So that would be here. So for every rows, you start with count as 0. So that is what we are initiating CO variable as. And then if the value is 1, so here if not CO, then we'll get the index of the j. So first we'll increment CO, and then we'll get the column index, which is nothing but j. Else we'll increment 1. So for every row you check if the counter is equal to 1, and then if the column counter of the column index is equal to 1. So which would say that the column is also 1, so we can add it to the result. So now the result can be incremented to 1, and then we can return the result. Yes, this works. So I'll submit it. Yes, we got it. So the important thing here is we are doing two pass, and anyhow it's going to be O of n square. But to just not get confused, I think this would be a better first time approach to start with, and then you can think about making it one pass. I'm not going to do one pass now, so I'm pretty okay with this approach right now. Probably I have to look for better approach for one pass, and if I get it I would post it in the next videos. But to start with, this would be a good starting point, and understanding the problem statement and coming up with solution. I think this is okay. It's an okay solution, not the perfect solution. Yeah, so you guys can think about a better one pass solution, and you can post it in the comments. So thanks a lot, guys. See you next time.